Hello students, welcome to Saurav Sir's classes. Today we are going to solve CAT 2017 question paper. In our last videos, we have solved questions up till 81. So now we are going to start with question number 82. So question number 82 says, from a triangle ABC with sides of length 40 feet, 25 feet, 35 feet, a triangular portion GCB is cut off. Okay, so we have a triangle ABC. So let us draw a triangle ABC. Seeing the sides, we can say that the triangle is an scalene triangle because we have all the three different sides, but we can't draw a scalene triangle here. So let us assume this to be a scalene triangle where we have 40, 25, 35. This looks quite unnatural, but let us assume this to be our triangle ABC. So here we have triangle ABC. A triangular portion GBC is cut off where G is the centroid of ABC. Okay, so we have been given that G is centroid of ABC. So let G be somewhere here. So this is our point G. So let us draw each lines till the vertex of the triangle from the center. So here we have the vertex P and here we have the vertex C. So we have this point known as G, that is the centroid of the triangle. So we have been said a triangular portion GCB. So let's check. This is the triangular portion GCB is cut off. Okay, so this part has been cut off from the triangle where G is the centroid of the triangle. Okay, so the area in feet, square feet of the remaining portion of the triangle ABC. Okay, so the remaining portion of the triangle is this triangle AGB and triangle AGC. So this is the remaining portion, therefore we need the area of this green shaded region. So let us find the area of this region. So as we know, according to a triangular rule, that if we have a triangle here and if we have a centroid of this triangle, therefore this centroid divides the triangle while joining with the vertex into three equal areas. So this area and this area are always equal of irrespective of the triangle, whether it's a scalene triangle, a isosceles triangle, or a equilateral triangle. So it is applicable in every triangle, therefore it is also applicable in our this triangle ABC. So this part is the 1/3 of the triangle. Triangle GBC will always be the 1/3 of the triangle, that is GBC is always 1/3 of area of ABC, that is the complete triangle. This is the area GBC is 1/3. Therefore the remaining portion, leaving GBC, this will be remaining portion will be equal to 2/3 of area of triangle ABC. So we need this 2/3 area of triangle ABC. So let us find this. So here we have 2/3. We have three sides of the triangle, so we can do this with Heron's formula. You must be remembering Heron's formula from old school method. Let me restart it from the very beginning. The formula is root over s into s minus a into s minus b into s minus c, where a, b, c are the sides. This is our a, this is our b, and this is our c, and s is equal to, here we have s equal to a plus b plus c divided by 2. So basically this is the general formula, general Heron's formula. So let us start with our calculations. So here we have, first let us find the s. S is equal to a plus b plus c by 2. So here we have a as 40, b as 35, and c as 25. So this will be 40 plus 35 plus 25 divided by 2, which is equal to 100 by 2, which is 50. So our s is 50. So let's put the values here. Here we have 2 by 3. In brackets we have root over 50. Here we have 50 into s minus a, that is 50 minus 40, that will be 10, into we have s minus b, that is s minus 35. So it will be 50 minus 35, that is equal to 15. So here we have 15 into s minus c, that is s minus 25, that is 50 minus 25. So it will be 25. So here we have 50 into 10 into 15 into 25. So let us solve this. Here we have 2 by 3 root over, so multiplying these four digits, we will get our resultant to be 1,87,500. So let us root this. So we have 2 by 3 into root over. Okay, so directly we need to solve this here, so it will be something. So let us keep 2 outside. Solving this without calculator is a difficult job, but we will do this. So let us keep this outside. Let 3 be inside of the root over. So it is divided by 9 because 3 is getting inside the root over, so it's dividing by 9. So this will be basically 2 by 2 into 250. And so root over will not be there. We have here 2 into 250 by root 3. This is what we are left with from this equation. So our answer will be 500 by root over 3. So let's check the options. So option number B matches with our answer, hence option B is the correct answer to this question. So now let's move on to our next question, that is question number 83. So question 83 says, let ABC be a right angled isosceles triangle with hypotenuse BC. So let us draw that triangle. So here we have triangle ABC with hypotenuse BC. So here we have our triangle, and this one is A, B and C. Since this is isosceles triangle with hypotenuse BC, therefore these two sides are equal, which is 6. Okay, so we have been said afterwards. So let us continue. Let BQC be a semicircle away from A with diameter BC. Okay, so we have a semicircle on BC away from A. So this is our semicircle where this point is Q. So this is our BQC semicircle. Now let's continue. Let BPC be an arc of a circle centered at A, lying between BC and BQC. So here we have our BC, this one is BQC, therefore BPC is an arc. So it will be something like this. This is the arc of a circle, therefore we can say that our this BC and this ACAB forms a quadrant, and our BQC forms a semicircle. Here we have a semicircle. So we have a quadrant here, we have a semicircle here. So let's see what in it. If AB has a length 6 centimeter, okay, so we have been said here that AB is 6 centimeter, which indicates that AC is also 6 centimeter because this is an isosceles triangle. In isosceles triangle we have two equal and one different side where BC is hypotenuse, therefore both the perpendicular and the base will have the same length, that is 6 centimeter. So the area in square centimeter of the region enclosed by BPC and BQC. Okay, so we need the area enclosed by BPC. Once again, this one is point P. So our area enclosed by BPC is this one, and area enclosed by BQC is this one. So basically we need this total area. We need this total area. So let us start finding the area. So here we have been given that AB is equal to AC equal to 6 centimeter. So let this be equal to A for our convenience, for our calculation. So it will be easier to calculate with A rather than with 6. So let us continue here. So here we have BQC. Here we have BQC, a semicircle on this hypotenuse. So let us first find the length of the hypotenuse. So length of the hypotenuse will be, this will be, let BC is the hypotenuse, BC square equal to AB square plus AC square, and root over we have, this one will be root over AB is A, so this one will be A square plus AC is again A, so this one will be A square, so this one will be 2A square root over, which will be equal to A root 2. So this is the length of this one, A root 2. So this one is the diameter for the semicircle, therefore the radius for the semicircle, radius for semicircle is equal to diameter by 2, this is diameter divided by 2, which is equal to A by root 2. So this is the radius of our semicircle. So let me mark this. Here we have radius of semicircle. So now let's proceed with the radius of the quarter circle, which is BPC. So here we have a quarter. As I said earlier, this one is a quadrant of a circle, this one exactly quadrant. Therefore here you can see that this is 6 centimeter, therefore the radius is 6 centimeter. So let us write here radius of quadrant BPC is equal to 6 centimeter, which is A. Therefore this is the radius. Therefore let us find the area of semicircle here. First, area of semicircle, this one we have a by root 2 as the radius. So area of semicircle is pi r square by 2, where r is the radius and we are dividing by 2 because this is a semicircle, so it will be divided by 2. So here we have pi by 2, r is a by root 2 whole square. So solving this we will get pi a square by 4. So this is our area of semicircle. Now let us find the area of quadrant. So here we have area of quadrant is pi r square by 4, because a quadrant is the 1/4 part of a circle, so we are dividing it by 4, equal to pi by 4. Here we have radius a, so this will be a square, which is pi a square by 4. So here we have got the area of semicircle and area of quadrant, so we need the sum of both. Therefore area of BQC and BPC is equal to pi a square by 4 plus pi a square by 4, which is equal to pi a square by 2. Now we know our a here, as we have assumed this is a is 6 centimeters. So let's put the value here. So this will be pi into 6 square by 2, which is equal to pi into 36 by 2, which will be 18 pi. So our answer to this question is 18 pi. Let's check the options. So option number, yeah, option number B matches with our answer. Hence answer to this question is option B. So I will like to end this video here. You will find solutions to the further questions in our next